The last thing I'd like to talk about in this section is how to find those absolute extreme values on a particular closed interval AB. Because remember, we need to live on a closed interval in order to be guaranteed absolute extreme values. So if I think about where our absolute extreme values can occur, one place we saw pretty often was endpoints. So if I look at this graph to the right that I've drawn here, here is my absolute maximum. That's the highest point on my graph on this particular interval. So they can occur at endpoints or they can occur at local extreme values because this is both a local and an absolute minimum value. So we know that these absolute extreme values will either occur at endpoints. Well, those are easy enough to find. Those are going to be given to us in our interval. Or at local extreme values. Now we said local extreme values, if they occur, must occur at critical points. So what we're going to do in these problems, we're going to start by finding the critical points of f on our closed interval AB. And this is exactly what we did in the last section. Actually, critical points on our open interval, AB. We are going to evaluate f at both the critical points and at the endpoints of our interval AB. So we're just going to take all of the critical points that we find along with the endpoints and plug those into our function. And then we need to just remember, what is the absolute maximum and the absolute minimum? Well, it's just the largest y value and the smallest y value. So I'm going to pick out the largest y value that I have. That is my absolute maximum. I'm going to pick out the smallest y value I have. That's my absolute minimum. So let's look at a couple of examples here. I have f of x equals x to the fourth minus 4x cubed plus 4x squared, and I'd like to work on the interval -1 to 4. So I'm going to start, step 1 says find the critical points. So let's find our derivative, f prime of x here. This will be 4x to the third minus 12x squared plus 8x, excuse me. And then I want to think about places where my derivative is either 0 or places where my derivative is undefined, places where it does not exist. So let's see, f prime equals 0. Let's take 4x cubed minus 12x squared plus 8x, set that equal to 0 so that we can solve. Here I see a factor of 4x, and that will leave me with x squared minus 3x plus 2 is equal to 0. And then let's see, I can take 4x, that will leave me with x minus 2 times x minus 1 is equal to 0. Take each factor, set it equal to 0, so 4x equals 0, x minus 2 equals 0, x minus 1 equals 0. This gives me x equals 0, x equals 2, and x equals 1. So a couple things I want to check here. First thing I want to do is I want to check that all of those points fall in our interval between -1 and 4, because those are the only x values I'm considering right now, are the x values between -1 and +4. Well, 0, 1, and 2, those are all between -1 and +4. So we're good there. The other thing, remember, that we're looking for when we're thinking about critical points, we need to think about the domain of our original function f of x. When we look at the domain of this function, f of x, as we look at it right here, is a polynomial. So the domain in this case is -infinity to +infinity, which means that there are no restrictions on my domain. In other words, all three of these are critical points. So I have 3 so far: x equals 0, x equals 2, and x equals 1. But I also need to consider places where the derivative does not exist here. And for that, I will look at the derivative that I found. So 4x cubed minus 12x squared plus 8x. Again, f prime of x is a polynomial, which means that it exists everywhere. which means that there are no additional critical points that are going to arise from this case because there are no x values that make our derivative undefined or that make our derivative not exist. So these three that I found, 0, 2, and 1, those are the only critical points that I have. So that is all step 1. Everything I've done here, that's just step 1. And this should feel very similar, identical to what we were doing at in our last video. So okay, we've found our critical points. Now we need to evaluate f. It says evaluate f at the critical points and at the endpoints of our interval AB. So essentially I'm just going to be taking these critical points along with the endpoints of my interval, -1 and +4. I'm going to plug those into my original function f of x. And then at the end of it, I'm just going to pick out what's the highest y value, what's the lowest y value. So let's work with the critical points. First, f of 0, this is 0 to the 4th minus 4 times 0 cubed plus 4 times 0 squared. Here I should just end up with 0. So okay, very cool. Then I'll say, how about 2? F of 2, this is equal to 2 to the 4th minus 4 times 2 cubed plus 4 times 2 squared. Here in this case, well, we will also end up with 0. Then I'll take 1, f of 1, so let's see, f of 1 is 1 to the 4th minus 4 times 1 cubed plus 4 times 1 squared. Here in this case, I end up with 1. So I've plugged in my 3 critical points. I also need to plug in the endpoints of my interval. So I'm going to plug in -1 and +4 as well. So f of -1, this is -1 to the 4th power minus 4 times -1 to the 3rd plus 4 times -1 squared. Here in this case, I end up with a +9. And then I'll do the same thing with 4 here. So f of 4, this is 4 to the 4th power minus 4 times 4 to the 3rd plus 4 times 4 squared. So if I plug 4 in here, this time I get 64. Oops. 64. There we go. At this point, I'm just picking out what is the highest y value and what is the lowest y value. That's how I want to end these problems, is just identify what's my absolute maximum, what's my absolute minimum. My absolute maximum looks like my highest y value right here is 64. So I'm going to say my absolute maximum is f of 4 is equal to 64. And the reason I'm writing it this way is 2 reasons. First of all, when we talk about an absolute maximum or an absolute minimum, we're always referring to the y value because we want to know what is that highest y value or what is that lowest y value. But by writing it in this way, f of 4 equals 64, we're also allowed to say right here that it occurs at an x value of 4. So I actually know the exact coordinates of this absolute maximum. It's at 4, 64. The absolute minimum, in this case, is a little bit tricky because here, look at this. I've got 0 and I've got 0. So in this case, 0 is tied for the lowest y value. So the way I'm going to write my answer, I'm going to say f of 0 equals f of 2 is equal to 0. That is my absolute minimum. So that is my problem, essentially. I've got my absolute maximum, it's 64, and it occurs at x equals 4. I've got my absolute minimum, and it occurs at x equals 0 and x equals 2. Let's take a quick break here because my stylus is actually about to run out of battery. So I'm actually going to have to break this last video up into 2 separate videos. We'll look at one more example of finding absolute extreme values in the next video.